In this lecture, I am going to introduce you to the concept of finite element analysis. So coming to the industrial design cycle, first we start with a design concept and we are going to model this particular design concept in either 3D using the 3D CAD softwares such as SolidWorks, CATIA, ProE and other sorts of available softwares. And you can also design these concepts in 2D using the 2D modeling softwares like AutoCAD, ZWCAD, etc. So once you finished modeling this particular design concepts, then the next stage is to analyze the design. So what happens in this particular stage, we are going to virtually test whether our product design is going to withstand all the loads it is going to come across in its life, or otherwise let us say if it is being used in high temperature zones, then what we can do is we can virtually test and see whether it can withstand the operating temperatures for that particular product or not. So likewise you are going to analyze the total design, and once you analyze the total design, then you will come to the stage of design optimization where you are going to try to optimize the product design. So in these two stages of design analysis and design optimization, we can use CAE softwares which are based on the process of finite element method or finite difference method or BEM method, such as Ansys, Abacus and Nastran, and there are other lot of CAE softwares that are available in the market. Once the product design has passed through these stages, then comes the stage of design evaluation and finalization, and once the design has been finalized, then the process of manufacturing and its production quantities and then quality, how we can control the quality and how we can package this particular design and send it to the customer will be planned. So throughout all these four stages, we can use the softwares known as the computer aided machining softwares or CAM softwares like MasterCam, and there are other lot of softwares which you can use for this particular four stages. And once the product is going to pass through these four stages, it is going to be sent to the customer or into the market for sale, and then the feedback is again taken from the customer, and then the new design concepts are going to be prepared, and likewise this design loop will be carrying on. And then again, if the product is going to fail at design analysis phase or the design optimization phase, we are going to resend it to either design concept stage or otherwise design modeling stage. So this is how an industrial design cycle works. So for the design analysis and design optimization phases, we are going to use the FEA softwares like Ansys, Abacus, Nastran, NX and other sorts of softwares that are available in the market. Then, so what are the major ways in which any engineering problem can be solved? So any engineering problem can be solved in three ways. One is the analytical method, second one is the numerical method, third one is the experimental method. So in the analytical method, it is nothing but a classical approach where we are going to use the theories of say theory of elasticity, theory of plasticity and other sorts of theories to solve the problem. In this particular method, we are going to get 100% accurate results, and the solution is a closed form solution. But the main drawback is this particular method can only be applied for simple problems like cantilever beams, simply supported beams and other sorts of very simple problems, and it is complete in itself. Then coming to the next method, it is nothing but the numerical method. So numerical method is nothing but we are going to prepare the mathematical representation of the engineering problem, and then we are going to take some assumptions in order to simplify those mathematical equations, and we are going to solve those mathematical equations. So this particular numerical method can be applied to solve any engineering problem even though the physical prototype is not available. So this particular method can be applied to solve real world complicated problems, whereas analytical method, if we take analytical method, if we want to solve complicated problems through analytical method, it is very difficult, and sometimes we need to approximate, and then we cannot get a fully closed form solution. Then this numerical methods, the results which come from this numerical method cannot be believed blindly. So what happens is we should be either using some form of analytical method or some form of experimental method to verify the results that are coming from the numerical method. Then coming to the third type, we can solve any engineering problem using experimental method. So what happens in an experimental method, we are going to take the actual measurements. So what happens is, if we are going to find out the deflection of a beam, we need to set up all the weights and all the boundary conditions in an actual setup. Then we need to take some extensometers, and then we are going to measure the strain, stress and deflection and other sorts of things. And it is a very time consuming as well as it needs very expensive setups. So in order to perform experiments, you need to destroy the product. So it is a very expensive process, and likewise it also is a time consuming process. And see, it is only applicable for the physical prototypes. Then results cannot be believed blindly, and a minimum of say 3 to 5 prototypes must be tested in order to find the accuracy or find an accurate behavior of the particular product through experimental method. Then so here you can see we have taken a beam with a load applied on the top face. Then you are having some formulas to solve, and we are going to get the deflection of this particular say beam through delta B equal to PA square by 6EI into 3L minus A. So likewise here is an example where we have used some FEA software in order to solve the similar type of problem, but we haven't created any equations by ourselves. We are going to give the software an input and it is going to give us the results. And coming to this experimental method, you see we had to take the physical beam and we need to apply the physical weight, and then we need to take some strain gauges in order to measure the strain, deformation and other sorts of things. And this is a time consuming thing to set up, as well as in order to run these experiments we need lot of money also. So generally most of the people early in the design, they perform this numerical method and then only they are going to perform the experimental method. Coming to different types of numerical techniques, there are different types of numerical techniques like say FEM, finite element method, FVM, finite volume method, FDM, finite difference method, and BEM, which is nothing but boundary element method. So coming to boundary element method or BEM. So just like finite element method, it also requires nodes and elements, but as you see in the name, if we are going to perform any analysis using BEM, it is going to consider only the surface or the boundaries of the particular system. So for example, if we take a volume, then it is going to consider the top surfaces only for the analysis. Likewise, if I take an area, it is going to select only the edges for analysis. So for example, let us say this is a total box. So what happens when we are using boundary element method, it is going to consider and it is going to perform analysis only on this particular surfaces. It is not going to take up this inner material. Then likewise, if you have an area, let us think this is an area, then it is going to consider only this edges for the analysis. The main advantage with BEM is the dimensionality of the problem is going to be decreased. So what happens, the solution time is much less, and this particular BEM method is very effective in solving problems involving acoustic analysis and noise vibration analysis. Then coming to finite volume method. So what happens in finite volume method, instead of taking nodes and elements, it is going to take volumes to calculate the results. So what happens, the unit volumes are considered in the finite volume method like that of a finite elements that are considered in FEM. So what happens is instead of dividing a particular geometry into different number of elements, it is going to divide a body into number of volumes. See here in this picture, you will be able to see that this particular geometry is being divided into number of cubical volumes. Likewise, different variables such as pressure, velocity, area, mass, etc. can be calculated, and then this particular total method is based upon the Navier-Stokes equation. like say mass, momentum and energy conservation equilibrium equations. Then coming to the applications of FEM, every CFD software or computational fluid dynamics software which is used to perform fluid analysis, like for example here you can see in this image this particular plane is being tested for the airflow over it. So what happens, in order to test such type of flows you need to apply the method known as CFD, which using this FEM technique we are going to solve for the fluid flows as well as this type of electronic cooling problems and other sorts of problems. Generally all the CFD softwares will be using the technique of FVM or finite volume method. Then the next method is the finite difference method. So coming to the finite difference method, it can be said as a combination of boundary element method and the finite volume method, and generally this particular FDM is very much applicable to solve CFD or thermal coupled problems. So coming to what is FDM, so the finite difference method is nothing but it is a way in which we can solve differential equations. Generally an engineering problem will be defined in the form of a differential equations, and this FDM method is one of the technique that can be used to solve these differential equations. So what happens, we are going to use the Taylor series to convert this differential equation into an algebraic equation so that we can solve the algebraic equation more easily. But in the process of conversion what happens, higher order terms are going to be neglected. For example, here you are going to see a coupled analysis of a lungs wherein you are going to see CFD analysis in the first stage, and then you are going to use those results in order to find out the pressure and the stresses that are going to be developed inside the lungs. Likewise, you can use FDM to solve coupled problems. Then finally coming to our basic concept of FEM or FEA, finite element method or finite element analysis. So for example, let us see, we have created this say complicated Lego building. So in order to create this complicated Lego building, we need to use such type of simple parts, so or such type of simple objects. So we are going to set one object on other, and in order we are going to set one object on other in a systematic manner so that we are able to construct this particular complicated building or say model. So the finite element method is also nothing but it is based upon the idea of building a complicated object by the use of simple blocks, or say we are going to take a complicated object like this and we are going to divide these complicated objects into smaller pieces and more manageable pieces in order to solve that particular problem. So why are we going to apply this FEA or FEM, and what is the necessity that we are going to learn this particular software? So FEA provides a way for virtually testing a product design. So without even going to the actual product, we can test the performance of the product and we can make the necessary changes without having costly delays in time or without having a lot of expenses incurred. It helps us to understand the design and implement appropriate design changes in the product development process. The adoption of FEA in the design cycle is driven by the market pressure, because what happens, if you are going to design a new product and you want to be competitive, you need to bring that product at lower price, higher quality in very less time. So in order to meet all those expectations, you need to use the FEM in a very early stage of the product design, and if you are able to effectively use this FEM technique and evaluate the product designs virtually, you will be having a lot of inherent advantages. So in the next lecture we are going to see some important terms used in FEA and what is the design procedure applied and what is the analysis procedure that is applied while solving the FEM problems.